Take a look at this. On the left is a plain text file with a short story in it. On the right is a small program. Watch what happens when I run that program on that file. There it is. It tells me the file has 215 lines. It tells me there are 2,141 words in it. It lists the 10 words that show up the most. The appears 141 times, at 46 times. And at the bottom, it points out which lines are longer than 80 characters, by line number. In the next 25 minutes, you're going to build that exact tool from an empty folder on your computer. Not copy it, build it, one line at a time, and understand every line. You don't need to know any Python to start. You don't need to have written a program before. If you can type and click, you can do this. One quick note before we get going. The voice you're listening to is a synthetic voice generated by AI. Everything else here is real. The code was written and tested on a real machine, and every error you'll see me hit, I hit on purpose, so you'll recognize it when it happens to you. So what are we actually building? A text analyzer. You hand it the name of a text file, and it tells you 4 things about that file. How many lines it has, how many words it has, which words repeat the most, and which lines are unusually long. Writers use this to check their drafts. Students use it on essays. Developers use it on log files. It's a command line tool, which means it doesn't have buttons or windows. You run it by typing a line of text and pressing enter. That sounds old-fashioned, and it is, but it's also the fastest way to build something useful in your first hour of programming, because you don't have to design a single screen. We need 2 things installed: Python itself and a code editor called Visual Studio Code. Both are free. We're going to install both together, right now, step by step. If you already have them, you can skip ahead using the chapters in the description below. First, let's find out whether Python is already on your computer. To check, we use the terminal. The terminal is a window where you type instructions to your computer as text instead of clicking on things. Every computer has one built-in. It looks plain and a bit intimidating, and it is neither of those things once you've used it twice. On a Mac, hold Command and press the spacebar. A small search box appears in the middle of your screen. Type the word terminal and press enter. On Windows, click the Start button, type PowerShell, and click Windows PowerShell in the results. Either way, you get a window with a blinking cursor waiting for you. In that window, type this exactly: Python, the number 3, then a space, then 2 dashes, then the word version. So, Python 3, version, 2 dashes, not 1. Then press enter. One of 2 things happens. Either you see something like Python 3.1 2.4, a version number, which means Python is already installed and you're ready to go. Or you see a line that says command not found, which means Python isn't on this machine yet. If that's you, there's a link to python.org in the description below. The installer takes about 2 minutes, and everything after this point works exactly the same. Look at your screen and see which one you got. Now here's something that trips up almost every beginner, and I want to fix it before it ever bites you. On Windows, the command is Python. On a Mac, the command is Python 3, with the number 3 on the end. There's no plain Python command on a Mac at all. If you type the wrong one, your computer answers, command not found. That message sounds serious. It isn't. It only means I don't have anything by that name. Nothing broke. Nothing was damaged. You type the other one and carry on. Throughout this whole video, I'm on a Mac. So every command I type will say Python 3. If you're on Windows, drop the 3. Next, a code editor. A code editor is a program for writing code. The same way, Word is a program for writing letters. You could technically write Python in Notepad or TextEdit, but you shouldn't. Those programs sometimes add invisible formatting. They save your file in the wrong format, and they give you no help at all. A code editor colors your code so mistakes stand out, lines up your indentation, and warns you when you've forgotten something. We're using Visual Studio Code. Most people call it VS Code. It's free, it's made by Microsoft, and it runs on Mac, Windows, and Linux. In your browser, go to code.visualstudio.com. There's one big blue button in the middle of the page that says Download. Click it. On a Mac, you get a zip file. Double-click it, and it turns into the Visual Studio Code app, which you then drag into your Applications folder. On Windows, you get an installer. Double-click it and click Next until it finishes. Open VS Code. The first time, you'll see a welcome screen with a lot of links on it. You can ignore all of them. What matters is the layout. A narrow strip of icons down the far left edge, a wide empty area in the middle where your code will go, and a menu bar at the very top of the window. Now we make a home for our project. Everything we build lives in one folder. I want to be specific about where, because create a folder isn't helpful if you don't know where to put it. We're putting it in your Documents folder. Not on the desktop, not in Downloads. Documents, because it's easy to find later and nothing cleans it up automatically. On a Mac, open Finder, the blue smiling face at the far left of your dock. In the sidebar on the left, click Documents. I keep a folder in there called Python Projects, just to stay tidy, and I'm going to work inside that. You can do the same, or just work straight in Documents. It makes no difference. Now right-click in the empty white space and choose New Folder. On Windows, open File Explorer, the yellow folder icon in your taskbar. Click Documents on the left, then right-click and choose New, then Folder. The new folder appears with its name highlighted, waiting for you to type. Name it exactly this: Command Line Text Analyzer. All lowercase, with hyphens between the words, no spaces. Press Enter. That's our project folder, and it's empty right now. In about 20 minutes, it'll have a working program in it. Back in VS Code. Look at the menu bar at the very top of the window and click File. In the menu that drops down, choose Open Folder. A file picker window opens. Navigate to Documents, click once on Command Line Text Analyzer to select it, and then click the Open button in the bottom right corner. VS Code might ask whether you trust the authors of the files in this folder. You created the folder, so click Yes, I trust the authors. Now look at the left-hand side. There's a panel called the Explorer, and at the top of it, in capital letters, is the name of your folder. Underneath it is empty, because there's nothing in there yet. Hover your mouse over that folder name in the Explorer panel. 4 small icons appear on the right-hand side of that row. The first one, the little icon that looks like a page with a plus sign on it, is New File. Click that one. A small text box appears in the panel, ready for you to type a file name. Type this exactly: text-analyzer.py. So it reads text-analyzer.py. A hyphen between text and analyzer. A hyphen, not an underscore. Then press enter. The file appears in the panel on the left, and it opens in the big empty area in the middle. That white space is where you type. Those last three characters, .py, matter more than you'd think. That's how your computer knows this is a Python file, rather than a note or a spreadsheet. It's also what tells VS Code to color the code and check it as you type. If you name it without the .py, nothing works, and nothing tells you why. We need something to analyze. In the description below this video, there's a link to the written version of this tutorial. Open it and scroll down a little to step 1. There's a blue button there that says Download Sample TXT File Zip. Click it, and a file called sampletxt.zip lands in your Downloads folder. A zip file is a squashed up bundle of other files. To open it on a Mac, double-click it, and a folder appears right next to it. On Windows, right-click it, choose Extract All, and then click Extract. Inside, you'll find two text files, dummy_text_file.txt and long_story.txt. Now drag both of those text files into your project folder. The easiest way, open the extracted folder in one window. Open your command line text analyzer folder in another. Select both text files and drag them across. Then look back at VS Code. The Explorer panel on the left updates on its own, and you'll see all three files sitting there together. Click on long_story.txt in that left panel to peek inside. It's a few paragraphs of ordinary English. Nothing clever. That's on purpose. We want a normal file, so the numbers our program produces are numbers. You could check by hand if you wanted to. Now click back on text-analyzer.py. Time to write some code. Step 1. We want to be able to type the name of any file when we run the program, so the program isn't stuck on one file forever. Those extra words you type after the program name are called arguments. An argument is a piece of information you hand to the program at the moment you start it. On the first line of the empty file, type import argparse. Let me unpack both words. A library is a bundle of ready-made code that somebody else wrote, so you don't have to. And import means go and fetch that bundle, so I can use it here. Argparse is Python's built-in library for reading arguments. It ships with Python, so there's nothing to install. Leave a blank line, then type definite main, def, space, main, open bracket, close bracket, colon. That creates a function. A function is a named block of code that does one job, which you can run whenever you want by calling its name. This one's called main, and it'll hold the main flow of our program. Don't miss the colon at the end. Press enter and notice what VS Code does. The cursor moves in from the left edge by 4 spaces. That gap is called indentation, and in Python, it isn't decoration. Everything indented under definite main belongs to main. When the indentation stops, the function stops. Python is one of the few languages where spacing changes the meaning. So let the editor handle it and don't fight it. Indented type. Parser is equal to argparse.argumentParser. Description is equal to command line text analyzer. Two things here. The equal sign creates a variable. A variable is a name you stick onto a value so you can refer to it later. And this one's named parser. And that description text is what shows up if somebody asks your program for help. Next line, still indented the same amount. parser.add_argument file. Help is equal to path to the text file. That tells argparse we expect one piece of information called file. And if the person running the program forgets it, argparse should complain. The help text is the one-line description that appears next to it in the help screen. Next line, parser.add_argument dash length type is equal to int. Default is equal to 80. Help is equal to max line length to check for long lines. The two dashes at the front of the word length mark this one as optional. Type is equal to int means whatever they type, treat it as a whole number. And default is equal to 80 means if they don't mention it at all, use 80. Then, args is equal to parser.parse_args. This is the line that actually goes and looks at what the person typed and pulls the values out. After this line runs, args.file holds the file name they gave us, and args.length holds the number. Those two names are how we'll get at them for the rest of the program. Leave a blank line and add two prints so we can see it working. Print f analyzing file args.file and print f long line threshold args.length characters. That little f before the quote mark lets you drop a value straight into the middle of the text using curly brackets. Without the f, you'd see the curly brackets printed out literally. Last piece for now. Go all the way back to the left edge. No indentation at all. Leave a blank line and type if dunder name is equal to ___ mine ___. Then on the next line, indent it. Those are double underscores on both sides of the word name. In plain terms, that line means if this file is the one being run, then start the main function. It's the on switch. Now save the file. Command is on a Mac, Control is on Windows. Watch the tab at the top of the editor. If there's a filled-in dot next to the file name, you have unsaved changes. And the program you run will be the old version. That dot has cost beginners hours. When it turns back into an X, you're saved. We need a terminal to run this. VS Code has one built-in, and using it saves you a lot of pain. In the menu bar at the very top, click Terminal, then New Terminal. A panel slides up from the bottom of the window. The important part, it's already sitting inside your project folder, so it can see your files without you doing anything. Now I'm going to run it wrong on purpose, because the error you get is genuinely useful. In that bottom panel, type Python 3 text-analyzer.py and press enter with no file name after it. Look at what came back. Line 1 reads, usage, text-analyzer.py, square bracket dash h, square bracket dash, dash length, length, file. Line 2 reads, text-analyzer.py, error, the following arguments are required, file. Read that second line slowly. It's telling you the program needs a file and you didn't give it one. Your program wrote that message. You didn't write a single word of it. argparse did, for free. Now let's do it properly. Type Python 3 text-analyzer.py. Y dummy underscore text underscore file.text. Length 100 and press enter. And there it is, analyzing file, dummy underscore text underscore file.text and long line threshold, 100 characters. Your program read what you typed and repeated it back. It doesn't do anything useful yet, but the plumbing works. One more thing worth seeing. Type Python 3 text-analyzer text-analyzer.py. Help and press enter. You get a proper help screen with the description you wrote and both arguments listed with their explanations. Every serious command line tool has one of these, and you got yours from 4 lines of code. Step 2. Actually read the file. And we're going to do it carefully because files go missing. People mistype names. This is where a lot of beginner programs crash with a wall of red text, and ours won't. Scroll up in your file and above definite main, add a new function. Type definite read underscore file path, then indented under it. Try, then indented again with open file path. R, encoding is equal to UTF-8 as F, then indented once more. Return f.readlines. Let me translate that. Open opens the file. The letter R in quotes means for reading only. We're not going to change the file, which is exactly what you want. The encoding part tells Python how to make sense of accented letters, curly quotes, and emoji. And readlines hands back every line of the file as a list. A list is Python's word for an ordered collection of things, kept in the order they came in. Picture a numbered shopping list. In our case, each item is one line from the file. First line first, last line last. That single idea carries us through the whole rest of this program. Now the safety net. Back out one indentation level with the word try, and type except file not found, then indented under it, print f file not found file path, and then return. Those last 2 characters are an empty pair of square brackets, meaning an empty list. Here's what try and except do. Python attempts the code under try. If something goes wrong, instead of crashing, it jumps to except and runs that instead. A problem like this is called an exception. It's the word for something going wrong while a program runs. So if the file isn't there, we print one friendly line and hand back an empty list. Now use it. Down in main, delete those 2 print lines from step 1. We don't need them anymore. And in their place, type lines is equal to read underscore file args.file. Then on the next line, if not lines, and indented under that, return. That means, if we got nothing back, stop here quietly rather than carrying on with nothing to work with. Save, and let's break it on purpose. In the terminal, type python 3 text-analyzer.py, y non-existent.txt, and press enter. Look at the output. One calm line that says, file not found, non-existent.txt. No red text, no crash, no stack trace. Your error handler caught it. That's the difference between a program that scares people and one that helps them. Step 3, and this one's short. Below your read underscore file function, add definite count underscore lines, and indented under it, return lay, lines. Lay is short for length, and it tells you how many items are in a list. Since each item is one line, the length of the list is the number of lines in the file. Down in main, after that if not lines, return block, add line underscore count is equal to count underscore lines, and then print f total lines, line underscore count. Save and run python 3 text-analyzer.py ydummy underscore text underscore file.txt. Mine says total lines 1. Just one. And that's not a bug. That file is one long paragraph with no line breaks in it anywhere. So as far as your computer is concerned, it genuinely is a single line. Hold on to that. It comes back later. That print line is temporary. By the way, We'll tidy it up in step 7, and I'll tell you when. Step 4. Counting words. There's one wrinkle. If somebody writes hello with an exclamation mark and somewhere else writes hello without one, we want those counted as the same word. Same with world followed by a comma or a word wrapped in quotation marks. So before we count, we strip the punctuation off. Go to the very top of the file under Import argparse and add a new line, import string. That's another built-in library, and the useful thing about it is that it already knows a full list of punctuation marks, so we don't have to type them all out ourselves. Now the function. Under count underscore lines, type definite count underscore words, lines, then words is equal to, then for line in lines, then indented under that, clean underscore line is equal to line dot translate, str dot make trans, string dot punctuation, then words dot extend, clean underscore line dot strip dot split, and finally, back out one level, return lay words. Let's take that apart. Words is equal to makes an empty list to collect into. For line in lines, starts a loop. A loop is a way of saying, do the same thing once for every item. So this runs once for each line in the file, and each time round. The variable line holds a different line. The translate line is the punctuation remover. Read it as, take this line and delete every character in Python's punctuation list. Full stops, commas, exclamation marks, quotation marks, all gone. And what's left goes into clean underscore line. It looks cryptic and it does one plain thing. Then strip shaves off blank space at the start and end of the line. Split chops the line into separate words wherever there's a space. And extend pours those words onto the end of our collection. Do that for every line, and you end up with one long list of every word in the file. That last line returns two things at once, separated by a comma, the count and the list of words itself. Python can hand back more than one value, and we want both, the number to display and the actual words for the next step. In main, under the line underscore count line, add word underscore count. Words is equal to count underscore words, lines, and then temporarily print f total words, word underscore count. Notice the left side has two names, because the function gives back to things. Save and run Python 3 text-analyzer.py. Y dummy underscore text underscore file dot text. Mine says total lines 1 and total words 1698. One line but 1698 words sitting on it, which tells you how long that single line really is. Step 5. Which words show up most often? We could build that by hand, but Python has a tool for exactly this called counter. You hand it a pile of words, and it hands back each unique word with a tally next to it. At the top of the file, under import string, add from collections import counter. That means out of the collections library, fetch the one tool called counter. Then below count underscore words, add definite word underscore frequencies, words, and indented return counter, word dot lower for word in words. The word dot lower part converts every word to lowercase before counting. Without it, Python, with a capital P at the start of a sentence, would be counted as a different word from Python in the middle of one. Lowercasing everything first means they're counted together, which is what a human would expect. What comes back behaves like a dictionary. In Python, a dictionary is a set of pairs, a key and a value. Like a real dictionary. You look up a word, you get its meaning. Here you look up a word. You get how many times it appeared. And counter adds one extra trick on top. That trick is most underscore common. In main, add freaks is equal to word underscore frequencies, words. Then a temporary loop. For word, count in freaks dot most underscore common, 10, and indented. Print f word count.
The 10 in brackets means, give me the top 10.
Save and run it. There's your leaderboard diam, libero, anti, fox, dog. Write down the list, each with its tally beside it. That sample is filler text, so the words look odd, but the counting is real. Step 6. Finding lines that are too long. This is the feature writers like. It spots the sentences that have run away from you. It's also where we use the length argument we set up right at the beginning. Under word underscore frequencies, type this single line function. Definite detect underscore long underscore lines. Lines, max underscore length is equal to 80. And indented under it, return I plus 1 for I.
Line in enumerate, lines, if lay line, max underscore length.
That second line packs a lot in. So we're going to slow right down and pull it apart piece by piece. Start with enumerate. When you loop through a list, normally you get the items but not their positions. Enumerate gives you both at once, a position number and the item. So each time round, I holds the position and line holds the actual text of that line. Why I plus 1? Because Python counts positions starting from 0. The first line of the file is at position 0. The second is at position 1. Humans count from 1, and your text editor shows line numbers starting at 1. Adding 1 converts Python's counting into the numbers you'll see in VS Code's left margin. Now the square brackets around the whole thing. That's called a list comprehension, and it's Python's shorthand for building a list in one line. Read it right to left in 3 parts. Part 1. Go through every line, keeping track of its position. Part 2. Keep only the ones where the length is bigger than max underscore length. Part 3. For each one you kept, put its position plus 1 into the new list. The result is a list of line numbers. In main, add long underscore lines is equal to detect underscore long underscore lines. Lines, args.length. Notice we're passing args.length, the number the person typed.
Add a temporary print, long lines, long underscore lines.
Save and run Python 3 text-analyzer.py while long underscore story.txt. You get a list of numbers in square brackets, 3, 28, 83, and on it goes. Every one of those is a line in that file longer than 80 characters, because 80 is the default we set way back in step 1. Let's prove that's real. The first number in my list is 3. I'll click on long underscore story.txt and look at line 3. Using the line numbers down the left margin of the editor. It's a long one. The program isn't guessing, it measured. Step 7, the last one. Right now our output is a jumble of test prints scattered through main. We're going to gather all of it into one function that prints everything neatly and then clean main up. Under detect underscore long underscore lines, type definite display underscore results, file underscore path, line underscore count, word underscore count, freaks, long underscore lines. Those 5 names in brackets are what the function needs to be handed in order to do its job. Then indent it. Print f backslash an analysis of file underscore path. Print f total lines line underscore count. Print f total words word underscore count. That backslash n inside the first one is a blank line. Backslash n is how you say start a new line here, inside a piece of text. It gives us a bit of breathing room between the command you typed and the results, so the output doesn't look cramped. Next, print backslash n top 10 frequent words. Then for word, count in freaks.most underscore common, 10, and indented under it. Print f word count. Those two extra spaces inside the quotes are deliberate. They indent each word slightly, so it reads as a list underneath the heading. Then the long lines part. Back out to the functions, normal indentation and type. If long underscore lines, then indented. Print f backslash n lines longer than threshold. Lay long underscore lines and print line numbers long underscore lines. Then else, at the same level as the if and indented under it, print backslash no lines exceed the specified length. If long underscore lines reads as if there's anything in that list. If there is, we say how many and list the line numbers. Otherwise, that's what else means. We print a friendly sentence saying nothing was too long. Without the else, a clean file would produce silence, and silence makes people think the program broke. Now the tidy up I promised. Go down into main and delete every temporary print we added along the way. Total lines,
Total words, the top 10 loop, and the long lines print.
delete the prints, but keep the lines that calculate things. Your main should now be 6 working lines and no printing at all. At the very bottom of main, add one line. Display underscore results, args.py, line underscore count, word underscore count, freaks, long underscore lines. 5 values. In the same order the function asked for them. That order matters. Swap 2 around and you'd get the word count printed under total lines. Save the file. Run it. Python 3 text-analyzer.py. Why long underscore story.txt. Read that output with me.
Analysis of long underscore story.txt. Total lines 215. Total words 2141. Top 10 frequent words, then the list. And at the bottom, lines longer than threshold, 17 with the line numbers.
That's the finished tool. You built it. Let's scroll through the whole file from the top and name what each piece does. 3 imports at the top. Argparse for reading what you typed. String for the punctuation list. Counter for tallying. Then 6 functions. Read underscore file opens the file and survives it being missing. Count underscore lines counts lines. Count underscore words strips punctuation and counts words. Word underscore frequencies tallies them, ignoring capital letters. Detect underscore long underscore lines finds lines over the limit. Display underscore results prints everything neatly. Each one does a single job, and each one is small enough to read in a few seconds. And main is the conductor. It reads your arguments, stops early if the file's missing, calls the 4 counting functions in order, and hands all the results to display underscore results. That last line at the bottom, the double underscore 1, is what kicks main off when you run the file. Let's test it 4 ways. First, Python 3 text-analyzer.py. Why dummy underscore text underscore file.txt. 1 line, 1698 words, and that 1 line gets flagged as too long. which is exactly right, because it's about 10,000 characters end to end. Second, Python 3 text-analyzer.py. Why dummy underscore text underscore file dot text, length 100. Same file, higher limit, and it's still flagged because 10,000 is still a great deal more than 100. Third, Python 3 text-analyzer.py. Why long underscore story dot text. 215 lines, 2000 words, a proper top 10 list, and 17 long lines flagged. Fourth, Python 3 text-analyzer.py. Why long underscore story dot text, length 50. Same file, but now we are stricter. And look, 152 lines get flagged instead of 17 because the bar has dropped. One program, 4 different questions answered. Now the part most tutorials skip. Something will go wrong. Not might will. So here are the 5 errors you're most likely to see, what each one actually means, and how to fix it in under a minute.
Number 1. ZSHA, command not found, Python.
This is the one we talked about at the start. It means your computer has nothing called Python. On a Mac, add the number 3. Python 3. On Windows, drop the 3. If Python 3 also says command not found, Python isn't installed yet. Go back and run through the installer. Number 2. Can't open file text-analyzer.py. No such file or directory. This means Python looked where you're standing and found no file by that name. Two causes: you mistyped the name or you're in the wrong folder. Check the spelling first. Hyphen, not underscore, and .py on the end. Which brings us to number 3. Being in the wrong folder. Your terminal is always sitting in one particular folder, and it can only see files in that folder. To check where you are, type pwd on a Mac and press enter. It prints the full path. If it doesn't end in command line text analyzer, you're in the wrong place. The fix that always works. In VS Code, close the terminal panel with the X on its right-hand side. Then open terminal, new terminal from the top menu again. It always opens inside the folder you have open. If you'd rather use your own terminal, type cd, a space, and then drag the project folder from Finder straight into the terminal window. It pastes the path for you. Press enter.
Number 4. Indentation error. Expected an indented block after function definition on line 3.
Indentation, remember, is the spacing at the start of a line. This message means you wrote definite something, and then the next line started hard against the left edge. Python needs that next line pushed in. Click at the start of it and press tab once. Number 5. Syntax error. 2 flavors. Syntax error, expected colon, means you forgot the colon at the end of a definite. An if, a for, or an else. Syntax error, unterminated string literal, means you opened a quote mark and never closed it. Both messages give you a line number. Go to that line and check the very end of it first. And one habit worth building. When red text appears, don't panic and don't retype everything. Read the last line of the message. First, that's where Python says what's actually wrong. Then find the line number. 9 times out of 10, the error tells you the answer in plain English if you slow down enough to read it. So what next? 3 things you can add to this in order of difficulty. First one, count sentences. You already know how to loop through lines and split text. Try splitting on full stops instead of spaces and count what comes out. Second, ignore the boring words. Words like the, and, and a dominate every top 10 list and tell you nothing. Make a list of those words and skip them before counting. Your top 10 suddenly becomes genuinely interesting. It starts showing you what the text is actually about. Third, add a top argument the same way we added length, so the person running it can ask for the top 5 or the top 20 instead of always 10. You already know every piece you need for that one. It's one more add underscore argument line and one number swapped in most underscore common. The full written version of everything we did today, with all the code you can copy and compare against, is linked in the description below. If your program isn't behaving, open that up and check your file against the final code block, line by line. That's usually the fastest way to spot a stray character. Thanks for building this with me, and I'll see you in the next one.